Your AI can't reach your database. 12 minutes from now, mine can. Yours too. Now, on to the AI learning.
Welcome to MCP Server Forge. In this session, you will build your first production-ready MCP server using Python or TypeScript. The course is delivered through DDS Vibe Academy and is completely free, making it easy for your team to start integrating AI tooling today. MCP is the Universal AI Tooling Port. It connects AI hosts to tools over the JSON RPC 2.0 standard. Instead of bespoke integrations, you build one compliant server and every compatible client can use it. Models automatically discover your server's capabilities during the handshake. MCP has become the de facto standard protocol. SDK downloads have grown 970 times in just 18 months, and more than 2,000 community servers are expected by early 2026. By adopting MCP, you eliminate redundant per-client integration code across your AI ecosystem. You can build MCP servers in either Python or Node. FastMCP targets Python 3.10 and above, installed via the UV tool. The TypeScript SDK targets Node 16 and later, installed from NPM. Both support stdio or streamable HTTP transports, so you can align with your existing stack. Match MCP to your production stack. Choose the language your team already operates in. Python favors decorators and implicit schemas derived from function signatures. Node favors explicit registration with strict XOD schemas. Both approaches deliver robust, typed capabilities. Let's start the Python build with installation. You need Python 3.10 or newer. Install the FastMCP framework and CLI tools using pip or the UV package manager. The CLI Extra includes the Visual Inspector UI, which you will use later for local testing and debugging. Next is Python implementation. FastMCP derives schemas directly from your type hints. Decorators such as mcp.tool convert ordinary Python functions into remote tools. Connection framing and protocol details are handled automatically, so you focus on business logic. For Python registration, all flags must appear before the server name. Use a double dash to separate the logical name from the execution command. Inject secure credentials via environment variables, so tokens never appear directly in your source or command line history. Before integrating with clients, validate your Python server in isolation. Ensure standard output is free of print statements that could corrupt JSON RPC. Use the MCP Inspector UI to exercise each tool visually and confirm that capabilities behave as expected. Now the TypeScript build, starting with installation. Configure strict Node 16 module resolution. Install the official core TypeScript MCP SDK from NPM and add the XOD library. XOD enforces strict input validation, protecting your server from malformed AI requests. For TypeScript implementation, instantiate an MCP server object that defines your name and version. Register each tool explicitly with XOD-typed input constraints. Instead of returning raw text, send structured data elements so AI clients can reason over your responses. TypeScript registration uses a JSON configuration file. Antigravity, for example, points directly to the compiled JavaScript entry point. Use the args field for executable paths and the env field for tokens. Variables expand securely at runtime using $syntax. Finally, wire up the TypeScript transport. Connect the stdio transport to route JSON RPC over terminal streams. Remember that standard output is your fragile data channel, so keep it clean. Use console error for operational logs to avoid corrupting protocol messages. To optimize capabilities, remember that models rely solely on tool descriptions. Write descriptions for AI comprehension, not marketing copy. Avoid vague comments and treat tool string names as stable public APIs that downstream prompts and workflows can depend on. Apply strict type narrowing to your schemas. Loose string-only inputs invite malformed, unstructured data from models. Instead, declare explicit fields with concrete types and constraints using XOD or typed schemas. This self-documents your tools for the model. Manage boundaries to protect agent attention. Very long capability lists dilute the model's focus. When a server exceeds about 20 active tools, split it into multiple domain-specific servers. This yields clearer intent, better routing, and more reliable behavior. Failure mode 1 is silent failures. When debug logs write to standard output, they corrupt the JSON RPC stream. The fix is simple. Route all server logging to standard error. This keeps stdout clean for protocol traffic and prevents hard-to-diagnose data issues. Failure mode 2 is versioning drift. Renaming tools silently break saved workflows that reference old names. Instead of renaming, add new capabilities while keeping existing identifiers stable. This preserves backward compatibility for all AI prompts in production. Failure mode 3 is authentication leakage. Inlining API tokens in configuration arguments writes secrets to disk in plaintext. Always reference credentials via environment variables using $brace syntax. This pattern keeps sensitive data out of your configs. To deploy safely, implement environment variable patterns for credentials. Verify standalone health with MCP Inspector, and register servers across Claude Code and Antigravity. The entire MCP Server Forge curriculum is free, with no sign-up, just practical guidance.